MSM3. We are on Unit 3, Lesson 3, and we are hitting the ground running with percents using equations and proportions. And I love percents and I love proportions. So this is one of my favorites. First, we're going to look at milk. Some students at Lebanon Middle School think that chocolate milk should be served in the cafeteria. A sample of students was surveyed, and 27 students out of 38 students surveyed agreed that chocolate milk should be served in the cafeteria. You can use a proportion to determine what percent of the students want chocolate milk. So one of the things we need to talk about are the parts of a proportion. So part is what part of the students said they wanted chocolate milk out of the whole group, which is out of 38 students. Now you'll notice that is one fraction in the proportion. 27 students out of 38, part over whole. Then you've also got one other part that you can, or one other piece that you can fill in is the percent. What percent of students want chocolate milk? Well, we don't know in this case. So that's where our variable is going to go. So we would say 27 students out of 38 students want chocolate milk. What percent? We don't know. And it's always out of 100. If every single kid, if 38 out of 38 said they wanted chocolate milk, that would be 100%. So it's always out of 100%. Now, when we are multiplying for our proportion to solve, we do what is called cross products. So the 27 gets multiplied by the 100. The x gets multiplied by the 38, and they get set equal to each other, and it is an equation. So 27 times 100 is 2700, and we have multiplication on the right. So we look at the side of the variable. Since there's multiplication, we're going to divide both sides, which is the inverse operation, and we would get about 71.1 is approximately x, and we'd say, oh, what were we solving for? We were solving for a percent. So we would say about 71.1% of students want chocolate milk. And because it was a word problem, we would want to have words in our answers. Now, another way to look at this with the part versus whole, sometimes you'll find is over of useful as well. 27 is what percent out of 38? And we'll see some more like that. Just want to put that in there, that part over whole also can sometimes be written is over of to help us find the numbers we need. Suppose there are 475 students at Lebanon Middle School. You can use your result from above to predict the number of students who think chocolate milk should be served at LMS. Solve using a proportion. So we're looking for the part of the population that wants chocolate milk out of the whole 475 students at Lebanon Middle School. And we already know the percent because we got it in the last question, right? The answer based on our sample was that about 71.1% of students wanted chocolate milk. So we would say, what is the part, we don't know, out of the 475 students that represents 71.1% out of the 100% who actually want chocolate milk? So we would do the same thing again. We would do the cross products where we would multiply 71.1 times 475, and we would set it equal to 100 times x, or 100x. So the multiplication on the left actually turns out to be quite a long number, and I would suggest using a calculator for that because multiplying, or the ability to multiply large numbers, is not what we're assessing here. And then over here on the right, 100x means 100 times x, so I will divide both sides with 100 by 100, and I will get the chance to move the decimal point over 2 places. 337.725 equals x. Now, guys, we don't have 337.725 kids, so we would say about 338 students want chocolate milk at LMS. And what did we really do here? We did not interview all 475 kids. We interviewed a sample. We found that 27 out of 38 said they wanted chocolate milk. We found that percent and then said, well, if that percent were true for the whole school, what is 71.1% of all 475 students? And we're predicting about 338 would want chocolate milk. Use a proportion to solve the following problem. So here's where that is over of part comes in. Is 66 is 29%. Okay, that's got a percent symbol. That tells me it's a percent. And then of what number? So the thing we don't know in this case is the of number. So the is number, the part 66 is, will go over x because we don't know what it is out of. And then on the right, 29%, always out of 100%. So first we have to set up our proportion, and then we start doing cross products. So 66 times 100 equals 29 times x. Well, 66 times 100, I could probably have even done that in my head and just written 6,600. Over on the right side, 29x multiplication. So I'm going to use division and divide both sides by 29 and get 227.6 approximately. Now, remember what we said before? We do prefer to have the variable listed on the left or listed first. So approximately 227.6. There we go. We also have a second question there. 35% of 139 is what number? Gets a little tricky. So let's start with the percent because there's a percent symbol with that number. Next comes of 139. So that's our whole. The thing we don't have, the is number, is what number? So 35% goes in that top right spot, always out of 100%. And then it says it's out of 139. So I'm going to put that on the bottom because our of number or whole out of 39 goes on the bottom. And the is number is the thing that we don't know, the part. What is 35% out of 139? So we cross multiply x times 100. On the other side, 139 times 35. This is not one that I could do in my head, so I wrote it down. When I multiply those two numbers, I get 4,865. Because the left side has the variable and it has multiplication, I'm going to divide both sides by 100. X equals 48.65. Now decimals are fine here because I don't know if this is about, people or tomato plants. It's just a general question, so I don't have to round that if it's not needed. The question over here on the left was a very long decimal, so I rounded it. But over here on the right, it terminated at 2 places, which meant I just wrote both of those places. Now on the back, we're going to look at another option, which is how to solve these using equations. So things we need to know when it comes to equations. It says to solve a percent problem using an equation, translate the words into symbols. So the word of usually means multiply. The word is usually means equals. So if we want to translate this into a proportion, we have a very specific pattern. If we want to translate it into an equation, we have a different pattern. So change the percent to a decimal and solve the equation. All right, so we're going to translate. What number? Don't know. That's our variable. Is means equals. 32%. Well, this says change the percent to a decimal. So 0.32. Of means multiply, and the number here is 509. So this, if I translate it one piece at a time, what number is 32% as a decimal of 509? Now in this case, both my numbers are on the right and I can just multiply them, which is fabulous. So 509 times 0.32, which represents 32%, x equals 162.88, and I would be done. I like this method. This one, however, was set up the easiest. When you look at the next one, 901 is, there's my equal sign, what percent, don't know, of, that's going to be my multiplication dot, and then 3219. So let's write this out. 901 is equal sign, what percent, don't know, of multiplication 3,219. So you'll notice this time the numbers aren't on the same side. So over here on the right is multiplication. I'm going to divide both sides by 3,219. And I'm going to get a decimal, which should not surprise me. I get the decimal 0.2799. And the reason it doesn't surprise me is that the missing thing was a percent. And remember, our percent, when we do this equation, is in decimal form. So if x equals 0.2799, when I want it in percent form, I would say x equals 27.99%, and I'd have to move that decimal point back into its proper location. So in the equation, it's a decimal. When I solve the equation, still a decimal. when I actually want the solution, the percent, I have to remember to take it from decimal form back out into percent form. 41 is equal sign 0.05%. Sorry, 0.5%. Move my decimal point 2 places and I get 0.005. Of what number? Well, I don't know. So of meant multiplication, and the what number is going to be my x. This is multiplication on the right, so I divide both sides by 0.005. Division gets rid of these. I have x remaining on the right, and when I do 41 divided by 0.005, I get 82. No, is that what I get? 82? Seems like it should be much bigger than that. 8,200. Okay, it's a couple decimal places off there. So 8,200. All right. Last but not, I mean, it makes sense that it would go in a lot of times. 0.005 is a very, very small number. So last but not least, 512 is equal sign. What percent? Don't know, so we put the variable of multiplication 317. Once I've translated it, this right-hand side is multiplication, so I'm going to use division. Divide both sides by 317. 512 divided by 317 is 1.615 equals x. Now notice, it's a pretty small answer. We were looking for a percent. So because we were looking for a percent, we have to remember to take it out of decimal form and put it back into percent form and start with the x on the left. Ooh, sorry, this one I should also have put my x on the left. There we go. Now everything looks good. And that's really the one sort of catch when it comes to using the equation, is remembering that the percent has to be in decimal form. But if you get your final answer, you have to remember to take it back out of decimal form and write the final answer as a percent.